Hello everyone. Today we are going to do a couple of experiments to learn about surface tension. Surface tension is one of the water's most important properties. It is the reason that water collects in drops, but it is also why water can travel up to plant stem or get to your cells through the smallest blood vessels. These experiments will teach students how the surface tension of water is formed and how strong it can be. So the materials needed are milk, food coloring, dishwashing soap, cotton swab or bud, bowl or transparent container, a ground pepper, bowl of water, straw, and thread. Experiment 1. Fill a clean soap-free bowl with water and sprinkle pepper over it. Put a tiny bit of dish soap on your finger or toothpick. Touch the surface of the water with soapy hand. Watch what happens. This experiments work because water is pretty sticky and one of its favorite thing is to stick to itself. Scientists call this surface tension. Soap, however, ruins all this happy hand rolling. So once soap is added, the surface tension breaks, but only in that one spot. The water all around the soapy spot is still holding hands and sticking together. That surface tension thickness pulls the water towards the edge of the bowl, taking the pepper along with it. Experiment number 2. Pour some milk into the plate or bowl. Squeeze a few drops of food coloring into the center of the milk. Just one drop per color is good amount. Then dip the end of the cotton swab into the dishwashing liquid. Touch the swab with the dishwashing liquid to the center of the milk and watch closely. What happens? Watch the color explosion. Why do the colors burst? That is exactly what you are seeing happening in the color explosion. In addition to water, milk contains a lot of fat and protein. Just like oil, the fat and protein molecules attach easily to soap molecules. When the soap touches the milk, it starts grabbing as many fat and protein molecules as it can. The attraction between soap and the fat causes the molecules to move quickly, creating the colorful explosion you saw. The experiment number 3. Pour a clean water into a transparent container until it's about 1 to 2 cm deep. Cut a piece of thread, tie the ends together tightly to form a loop. Gently place the loop of thread on the surface of the water. The loop should float without sinking or breaking surface tension. Note the shape of the loop. It may be irregular or randomly shaped. Now use a dropper to add a few drops of liquid soap into the clean water and stir it completely. Take 4 straws and join them together to make a square. Place the square inside the liquid container and raise it such that the soap bubbles settle on it. Now place the thread loop on the surface of the square straw with the bubble on the surface. Carefully tap on the inside of the loop without touching the thread and watch the loop respond. The thread immediately snaps into a perfect circle. The soap reduces the surface tension inside the loop, causing the outer tension to pull the thread outward evenly. So minimization of the surface area is what the thread loop experiment is doing. Liquid tend to adopt shapes that minimize surface area due to the surface tension. Among all possible shapes, the circle encloses the maximum area for the smallest perimeter. When a soap solution is introduced inside a floating thread loop, the surface tension inside decreases. The outer surface tension pulls the thread uniformly outward. The result is a perfect circle formed by the balance of forces around the loop. So this is how we can see that how surface tension plays such an important role in our daily life. So thank you and keep learning.